All right, good morning and welcome back. I'll say this is the third time I've done this because of an audio problem, but we're talking about exploring conic sections. And what are conic sections? We're going to find out as we do this that conic sections they're going to be circles, ellipses, hyperbolas, and then of course a parabola. And just knowing that that's what we're looking at when we talk about conic section. We will go into more detail for each one of these later on, but as we start with this first one is going to be a circle and graphing a circle, and the parent function of a circle is x squared plus y squared equals r squared. In case you did not remember that. Now going forward, we look at this, graph a circle, and it says right here, it says what is the graph of this look like, and what are the lines of symmetry, and what are the domain and range? Well, what does the graph of that look like? There are several ways to address this, but we know that x squared plus y squared is going to be equal to r squared. And let's see, if I was going to graph this, if I was going to graph any function, I would want to go ahead and solve for y, and then if I can solve for y, I can do some simple generic input, output, and come up with those values. So let's go ahead and do that first. Okay, so if I solve for x, go ahead and use my inverse operations here, and you can review that. You can pause and review it if you need to isolate my y. So I'm going to go ahead and get y by itself, and in doing so, of course, I subtracted x squared from both sides, then I turned around and was left with y squared. In order to get rid of y squared, of course, I found the square root, and the square root will cancel those two things out because it'll become a value of 1, and then we know that y is going to be equal to plus or minus the square root of 9 minus x squared. Now, in order to do some graphing, what I want to do is I want to create a table, and of course, x and y. And I know that one thing that I would do is if I would substitute in, so if I evaluated my function, so I have f of x equals plus or minus this. Now, if I went ahead and said f of 0, what do I get? I get plus or minus the square root of 9 minus 0, or plus or minus the square root of 9, which is plus or minus 3. So I do know, just some simple stuff here, that when x is 0, it is also y is 3, and when x is 0, y is also negative 3. And so I'm just going to go ahead and plug some values in. You can also use your calculator. Okay, so I've gone and used my calculator, looked at my table, and I was able to come up with some more points. And what I'm going to do is now I'm going to take and I'm going to graph these basic points and see what we can go with a circle. When I'm graphing these conic sections, I'm not expecting to do all the points, but I'm going to get some key points that I can in order to do my graphing. So looking here, we have, of course, you need your axes. Got my y and my x, and let's see. Okay, and I'm going to go ahead and graph those 6 points. So I'm looking at 3, 0. I'm sorry, negative 3, 0, 3, 0. I'm looking at 0, 3, 0, negative 3, and of course 2, and approximately 2.5, and 2.2, approximately 2 and 2.2, and the reflections. So, and what I want to do now that I've graphed my 6 points, these 6 points right here, I'm going to go ahead and I'm going to connect them with a smooth line. All right, so I've connected my dots with a smooth line, and I have a circle, and there's some things that I do know about this, that I know that my radius is going to be 3 units, because the the radius is constant, and I know that this value from right here is 3, and that is also my radius. And let's see here, what else do we need to know? It has asked us, what are our lines of symmetry? Well, if anything I draw through the center of this origin of the circle and I draw a straight line, I'm going to get I'm going to get lines of symmetry. This side is symmetric with this side. As long as I'm going through the center, I keep having symmetric. So with a circle, it's unlimited the amount of lines of symmetry that you can draw. And of course, we can simply look here too at our axes. Our axes represent lines of symmetry because the y-axis divides it in half vertically and the x-axis divides it in half horizontally. So both of those are independent lines of symmetry. So let's see here, domain and range. Well, let's look at domain and range, and we should hopefully remember that the domain is my x-axis, and then my range is referring to my y-axis. Okay, and let's see, looking at my domain, this function extends along the x-axis from 3 to -3. Okay, this is where it extends. So that means that my domain is going to be from 3 to -3. So it is going to be all values of -3. X is going to be greater than or equal to all values from -3 to less than or equal to 3. So that is my domain for all values of x that are greater than or equal to -3, but less than or equal to 3. And if we look at our range is going to be our y, and it's going to be all y values of, well, we know that the range extends to here, from here down to here. And this is going to be -3, 3. So my range is going to be for all values that are greater than or equal to -3, but less than or equal to 3. So there you go. There's my range and domain of this circle. And that was a long problem, really, but we tackled some concepts that we're going to gloss over in these next examples, because you're expected to know domain, range. You're expected to know how to input x into functions and get y values out so you can graph them. So as we go to this next example, right here, why are there no points in the graph with x coordinate of 6, which would be out here? Well, it's because our circle doesn't extend that far. Pretty simple. All right, let's go here to this ellipse. And graphing an ellipse, the length of the graph of 2x squared plus 2x squared plus y squared equals 18. To graph that, let's do the same thing that we did on that last equation. Let's go ahead and put it in terms of y so we can do some input-output values. So let's convert it to y equals. Okay, so now that we've converted this equation of an ellipse into y equals, we're going to go ahead and now graph some points so we can get this on our graph. And I am going to be fairly selective for my values. I'm, of course, going to pick values of x that will give me integer values of y, because I don't want to deal with any more fractions than I have to. So let's look at x's plus or minus 3, plus or minus 1, and 0. Okay, doing my inverse operations, I went ahead and substituted in here -3 for x, and when x is -3, y is going to be 0. And that's how I'm going to do the rest of these. So let's just go ahead and plug in some values. I'm going to have -1, 0, 1. I'm probably going to find another value for -1 at 1 and 3, and we'll see how this goes. Okay, and graphing those points, we're going to have X is -3, y is 0, and we have -1 and 4. We have -1 and -4. We're going to have 0, which is going to be -4.2, and we're going to have 0, which is going to be a +4.2. We are going to have 1 and 4, and 1 and -4, and then, of course, 3 and 0. So these are the values that I've gone and graphed, and what we're going to do is we're going to, again, connect them with a smooth line, smooth curving line. All right, so there we have it. Again, these points, I got some points that were very easy to plot and graph, so don't make things too difficult for yourselves. And it says, what are my lines of symmetry? Well, this one is going to be limited. We don't just have every unlimited like the circle. This line of symmetries for an ellipse are going to simply be, in this case, it's axis. We're going to find some translations later on, but I know that this case, my line of symmetry is going to be x equals 0 and y equals 0, which turn out to be my two axes. Let's see, and we're talking about domain, and when we did domain earlier, remember, it's your x-axis, so for all values of x such that the domain extends from here to here of this function, right, as we look at it on the coordinate plane. And of course, then that would be for all values of x which are greater than or equal to -3 or less than or equal to 3. And looking at my range, that is going to be for all values of y, that, goodness, a little bit more difficult, but thankfully we know, according to our table, that we extend upward to a +4.2 approximately, and downward to a -4.2. So we're going to have -4.2, y is going to be greater than or equal to, and then less than or equal to a +4.2. So there's my domain and range line of symmetries and those items on my ellipse. Okay, now let's look at graphing a hyperbola, which we have not done in math as far as I know up until now. So if I go ahead and just create my axes, and what I want to do here is, let's see, of course, we know we're going to have a center, and I'm going to go ahead and label my axes. Let's go ahead and take a moment, and in order to do some graphing again, let's go ahead and solve for y. Okay, I hope you've been able to isolate your variable and have, in this case, y is equal to the square root of x squared minus 16. So let's see, if we go from there, let's go ahead and we will plug in some values for x and plug in some values for y and see what happens. And let's go ahead and begin with, listen, we know we're not going to get much farther than -5 or greater than 5. So let's look at those values and say, okay, when x is 4, 5, -4, and -5, -5, and doing this, doing some substitutions, we'll quickly find out that when we plug these values back into this equation, that y is going to become 0, 3, -3, 0, 3, and -3. And in doing so, now we are able to plot some points. So take a moment and plot these points. Okay, so now that I have that conic section, now if we do some connecting of our points, well, we're going to find out that we have something that does this. And again on the other side. And that is the shape of a hyperbola. Plot enough points to see the pattern and then go ahead and connect it. Domain and range. Well, the domain is my x values, and it does not exist. It does not exist from here to here. This function doesn't. So my domain is for all x, for all values of when x is less than or equal to -4, or x is less than or equal to, I'm sorry, x is greater than or equal to 4. And then when I'm looking at my range is going to be very similar, except for all real numbers. So, and let's see, line of symmetry or axis of symmetry. Well, to me it looks like I can probably find a line of symmetry right here along the x-axis, and again along the y-axis. So again, those create the pancake or your mirror image of one another, that you can go ahead and change them and connect those to the following activities. So there we have it. We have graphed the three main conic sections: the ellipse, the circle, and the hyperbola. And we will continue on later on, but for now we'll go ahead and work on our problems, work on our assignment, and come back in a minute. Okay, so working to identify these conic sections, hopefully if we look over here to the right, I want you to be able to look at A and B and say, those are hyperbolas, whatever you may choose to call them, because of their shape and how we have a vacancy in the middle and we have what looks like two parabolas going outward forever. And looking at C, hopefully you can see that that is an ellipse, which looks like a stretched out, or an oval, a stretched out circle. And let's see, and what kind of characteristics do we know? Hopefully when you look at A, it says, what are the center and the intercepts? Well, looks like my center is right there for A, and my intercepts, looks like I have two x-intercepts, and that is x when x is -2 and x is 2 are intercepts. And then what are the domain and range? Well, hopefully we know that since this goes on forever, this way and this way and this way and this way, because that's what the arrows indicate, that technically the range is all real numbers because it goes on forever upward and downward. Whereas my domain does not exist. The function does not exist in here. So my domain is going to be for all values of x when x is less than or equal to 2, and then when x is greater than or equal to 2. So let me write that down real quick. Okay, hopefully when you're looking at that A example that you see the center, the x-intercepts, and the domain and range. Of course, there is no y-intercept because the function never crosses the y-axis. Skipping over to B, take a moment, look at that, tell me what my center, my x-intercept, my y-intercept, my domain and range are. All right, so looking at that, my center on example B is going to be 0, 0. I'm going to have no x-intercepts, but I do have two y-intercepts right there at 1, 0. I'm sorry, 0, 1 and 0, -1. And then my domain, this function goes on forever, left and right. So the domain is all real numbers. And then my y exists from 1, all numbers greater than or equal to y equals 1, and less than or equal to y equals 1. So we do not have this range area in here. So looking at range is going to be for all values of y, y is greater than 1 and less than or equal to -1. And let's do C real quick. Okay, so looking at the center of my ellipse, I'm going to have 0, 0. And then my y-intercept is going to be 0, 4, 0, -4. My x-intercept is going to be 6, 0, -6, 0. And my domain is going to be from right here, positive 6 to negative 6, and then my range is going to be from a positive 4 to negative 4.